bearing and distances. Bearing is simply the direction. Then distances, you understand that one, the distance between 2 points. The direction or the description of the location of something. Now, bearing. In bearing, you still use north, east, south, west. You use this coordinate in bearing. In bearing, the direction of angle is from the north and it goes through the east to the south, then to the west, then back to the north. So it is clockwise. Don't forget, clockwise. Bearing is in the direction of the clock. So you can say the bearing of something is 30 degrees from another point. The something may be here. If it is 30 degrees, this one is 0, 10, 20, and 30. When it gets to 30, you draw the line to the point. Okay, let's say this is the point. This 30 degrees. So that's bearing. If it is 60 degrees, it will be like this. Then that angle from the 0 to this line, the part of that object will be from here to here, 60 degrees. If it is 90 degrees, then it will be here, and the bearing is 90 degrees. If it is more than 90, let's say 120, it will be in this quadrant, and you draw it from there and you label it 120. If it is 120 degrees, that is bearing. If it is up to 180, this is 180. This is 270, and this is 360. So, like we learned in the angles between 0 and 360, this one is 0, this one is 90 degrees, this one is 270 degrees, and this is 180, I'm sorry. This is 270 degrees, and this is 360 degrees and 0 degrees. It is clockwise. It comes this way. Alright, that's bearing. There is another one. You can mention something like south 32 degree east. What does it mean? You start from the south. This is the south. This is the south. This is the east. This is the west. And this is the north. South means you start from the south. Where is the east? This is the east. So this south, you go to east. You are going to east, from south to east, and you stop at 32. When you begin to walk, when you are up to 32, you stop, and that's 32 degrees. Like in the example here, you have something like that. This is south 78 degree east. This is south 36 degrees west. That means you start from south, but you are going to west. And when you are going to west, you count just 36 degrees from south. Then you stop. Alright. Let's use this as preamble. Let's go back. Let's go to the example now. A tree is on a bearing this. Bearing is direction. If you are sitting here and you want to talk about the person over there, you can describe it with angle and distance. So a tree is on a bearing 36 degrees southwest from a point X, and on this bearing from a point Y. So there are 2 points now, from a point X, from a point Y. Somebody at point X and somebody at point Y, they are viewing the same tree. So since we don't know on which side it will fall, when you want to draw your diagram, start from the middle of your space. Now they said a tree is on a bearing this from point X. This is, let's say this is X. You have to draw the coordinate. Now from point X, south 36 degree west. This south, this east, this west, this north. South 36 degree west. It means you start from south, going to west, going to this side, is on this side, this quadrant. Then you are going to go 36 degree from that. So let's assume you go from here and this 36. So you draw. This is the tree. This is the tree. Let's say it's T. This point, we started from point X. This point X. Now a tree is on a bearing this from point X. This is the tree from point X. We put our compass here and we navigate to the tree, and this is 36 degrees. 36 degree west. Now they said it is now and on this bearing from point Y. On this bearing from point Y. Now this is southeast. That means if we draw the coordinates, let's assume we draw the coordinates. This east, this south. It will be on this side. It will be on this side. So that means it will be here. You draw it here. Now they said before we draw, let's consider the equation. If X is 200 meter due east of Y, 200 meter due east of Y, this is X. They say it is due east of Y. If X, this one, is due east of Y, this is X. If Y is here, that will be due west of Y, because that means the west of Y is here. But they said this X is on the eastern part, eastern side of Y. So Y is here. This Y. And it is 78 degrees southeast. So let's start from the south. This is the south, this is the east. So we go from south to east, 78 degrees. We count. Take our compass. We go. Let's say this is 78 degrees. Wow. It must come to this point. It must come to this point somehow. Let's say this is 78 degrees from south. You join it. From the center of the coordinate, you join it to the navigation here, then you extend it here. Let's say the tree is here. Since we did not work with the distance before, we just know the tree is on this part. Now this one has come to tell us the particular place, the specific point of the tree. So that's 78 degrees. Now if X is 200 meter due east of Y, this is east of Y, and it's 200 meter due east. Due east means the line that connects X and Y, they are on the axis, on the X axis. just straight like that, no deviation, not like this, not like this, but on the line, straight. When you hear due, sometimes you hear due west, that means you go to the western axis and continue on that line. You hear due north, you come straight, you go straight at the north like this, just on the axis you go straight. That's due north. Now they said it is 200 meter, 200 meter due east of y. Now calculate the distance of the tree from y to the nearest meter. The distance of the tree from y, distance of the tree from y. So this is what we are looking for. Let's use x to represent that. Now we have a triangle. We have a triangle. This is the triangle. Something like this. This is 200 meters. You need to find the angles inside, because you are working with the angles inside. Now the angles you have here, they are angles outside, but one good thing is that we know this from west to south we have angle 90. So from 90, 36 is outside. What will remain inside? To be 90 minus 36 degrees inside here. This one, everything here is 90, so 78 is outside. What remains inside is 90 minus 78 degrees. 90 minus 78, that is equal to 12 degrees. Now 90 minus 36, that's 54 degrees. So we now know this is 12 degrees and this is 54 degrees. Good. We have two angles known. We can easily get the third angle. The three angles sum up to what? 180. So if 12 has gone from 180, then 54 left, what will be the remaining? So let's say this is angle T, because this is 3. T now is equal to 180 minus the sum of others. So when you sum that, you have 66. 180 minus 66, 114 degrees. So angle T is 114 degrees. Remember, we are looking for x. Now we know the three angles, only one side. We are going to use sine rule. We are going to use sine rule. Okay, using sine rule for this triangle. We know all the three angles, we know one side. Now to use sine rule, you need a complete set. You know, there's a side, there's an angle in the formula of sine rule. So now that we have three angles and we have one side, this known side is needed, and what we are looking for is also required to be in the formula. Sine rule is A over sine angle A equals B over sine angle B equals C over sine angle C. Now we want to use this and this, so we have x over, the opposite of x is 54 degrees, sine 54 equal to, then want to use the other side that is complete. We have the angle known here, 114, T is 114. We have the side known, so the side comes up first, 200 over sine, opposite is 114 degrees. So you can cross multiply here. X equals, this one will go, so 200 over sine 114 times, this one has crossed, sine 54. Now let's solve sine 54 and solve sine 114. X equal to sine 50, we have 200, remember we have 200 over sine 114. Sine 114 is there, mention it, 0.9135 times, what about sine 54? 0.8090 now.
Yes.
Okay, so this is what we have. Let's solve this all together. Can multiply 200 with this, then divide by this. What do we have?
16. 161.8.
161.8.
Yes. Divided.
Okay, multiply, you have that. Divide by 0.9135. What do you have?
177.12.
177.12 meters. Because remember, what we used, the 200 we used there was a meter. It was a meter. These ones are in degrees, and the degree up, degree down, they cancel out. Meter has nothing to cancel it. So that's why it's this way. Answer X, the side X is this. Now calculate the distance from the 3 and Y to the nearest meter. That is what they want us to do, and that is what we have done. But to the nearest meter, that means you approximate. X is approximately 177 meters when you round it down. So that's a good example. All right, like somebody brought this question, you can always bring your problems and we're going to solve the problems together. Thank you. Remember to click the subscribe button below so that we can get you the updates of our lectures.